Beep ba 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 da bo. Ba 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 da bo. Beep ba 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 da bo. Ba 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 da bo. Beep ba 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 da bo. Ba 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 da bo. Beep ba 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 da bo. Ba 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 da bo. It's scat time. I mean math time.
Welcome. We're going to do something very cool. We are going to prove that 0 equals 1 with an airtight mathematical proof. So we're going to start with something we can all agree to be true. Minus 20 equals negative 20 here. It's the same number equal to itself. So we're going to start with this, and we're going to work our way down until we get 0 equals 1. So the first thing we're going to do is we're going to split minus 20 up on either side of the equation. We're going to do it differently. So on the left here, we're going to do 16 minus 36, which equals negative 20. And then on the right here, we are going to do 25 minus 45, which also equals negative 20. So right now, it's still negative 20 equals negative 20. Now we're going to split it up even further. So we're going to split up the 16 to 4 squared. 4 squared is just 4 times 4, which is 16. We're going to split the 25 to 5 squared. Again, these are both just different ways of writing the same number. 5 times 5 is 25. 4 times 4 is 16. So good so far. Now we're going to split up the 36 and the 40. So 36 is the same as 9 times 4, and 45 is the same as 9 times 5. We can put parentheses around those if you'd like. So right now we still have negative 20 on the left equals negative 20 on the right. Okay, so we're good to go. So now we're going to even split these up even more. Actually, before we do that, we're going to add something to either side. We're going to add the number 81 fourths. Now, it's a fundamental rule here that if you add a number that is equal to itself on both sides of an equation, it is still equal, right? The scale is still balanced. We're adding the same number on both sides. And then we're going to write the 4 squared the same. So I write 4 squared and 5 squared. And the 9 times 4 and the 9 times 5, we're going to change slightly. So we're going to change 9 times 4 to 4 times 2 times 9 halves. And they are the same. So let me just show you real quick. Okay, 2 times 9 over 2. These 2's cancel out, and you're left with just 4 times 9. You can try the calculator. This here equals 36, and this also equals 36. They are just different ways of writing the number 36. Now we're going to do a very similar thing with the 9 times 5. And again, if you do not believe me, this right here equals 45. It equals the same as this, and this right here equals 36, which is the same as this. Take a calculator out if you don't trust me and try it. So we still have both sides are equal. Note, this right here still equals negative 20, and this right here still equals negative 20. Then we added the same number to both sides, 81 fourths. Now I'm going to change 81 fourths into 9 over 2 squared. So 9 over 2 squared, mathematically, it's the same as 9 squared over 2 squared, which is the same as 81 over 4. So mathematically, this right here, and again, if you don't trust me, take a calculator, is identical to that. There is no difference, they're the same number. So I'm going to erase 81 fourths on both sides, and I'm actually going to add 9 over 2, and I'm going to square it. And I did the same to the right side. So we still have the equality. And again, trust me, these are the same. You can try a calculator. Okay, so next. It may not be obvious. We can now factor these. So on the left here, it factors down to 4 minus 9 over 2 times 4 minus 9 over 2. Now, you might be leery about that step I just did. Is this right here really the same as this? It is, and I'll show you real quickly how we can prove it. So we are going to unfactor it. To unfactor it, you have to multiply all the numbers out. So you have 4 times 4, that's 4 times 4, and then you have 4 times minus 9 over 2, so it becomes minus 4 times 9 over 2, and then you have minus 9 over 2 times 4, so it's another group of 4 times 9 over 2, and then finally negative 9 over 2 times negative 9 over 2. Negative times a negative is a positive, so it's positive 9 over 2 times 9 over 2. Now, if we take a look at this a little closer, this right here is 4 squared. Then we have two groups of 4 times 9 over 2. So we have two groups, 2 times 4 times 9 over 2. And then this right here, a number times itself can always be written with the exponent 2. So again, this here is the exact same as this up here. So I did factor it correctly. I promise you, if you're unsure about this factoring, I promise you this is correct. You can ask any of your math friends. And with the same reasoning, I can factor the right, but you have a 5 here instead of a 4 because you have a 5 here and here. And now, when you look at this, we have the same number multiplied itself on either side. So you can rewrite that with a square. Go down a little bit here. So on the left here, we have 4 minus 9 over 2 squared. That equals 5 minus 9 over 2 squared. And you could check with the calculator. This equal sign is true. This does equal this still. We have not changed the left side is still equal to the right side. And now, almost done here. We are now going to take the square root of both sides. And taking the square root of both sides is a way to get rid of the square. And if you're unsure about why that works, real quick, let's say you had 3 squared, and you want to get rid of that square. Well, if you took the square root of it, and again, I'm not going into all the math here, just real basically, this equals the square root, and now 3 squared is 9. We know the square root of 9 is 3. So again, we started with 3 squared, and by taking the square root of it, we got just 3. It's like canceled the square in a sense. Okay, if you're not sure about that, you can look it up. It is true. So we are left now with 4 minus 9 over 2 equals 5 minus 9 over 2. And I'm going to do some real basic algebra here. I'm going to add 9 halves on both sides. And this adds a 0 on both sides, so you're left with just 4 equals 5. And then the final algebra move, I'm going to subtract 4 from both sides. And on the left here, 4 minus 4 is 0, and 5 minus 4 is 1. Oh my goodness, look at this. We have just shown that 0 equals 1. Oh my god, all math that we know is going to crumble down into pieces. How can 0 equal 1? Well, the obvious answer is that it can't. It can't. There must be a mistake here. So let me show the whole proof again. So here it is. We start at the top with negative 20 equals negative 20, and we verified each step along the way, yet we got 0 equals 1. What is going on? So comment below if you think you can identify the mistake. And I want to say right now, it is not the factoring. This is factored correctly. So this highlighted row does equal this highlighted row. That is not the mistake. So see if you can point it out. If I don't hear back in a couple days, I will make a video explaining what went on here.